So hey guys, welcome to the channel Learning Competitive Programming with CodeChef. So if you want to learn competitive programming and master data structures and algorithm, this is the one-stop destination for you. So every week there will be several videos on the ongoing contest of CodeChef as well as past problems. So do subscribe to the channel and turn on the bell notification. So myself Chirayu Jain, I'm a CodeChef educator. I'm working in a product-based company. I'm from Jaipur Engineering College and Research Center. So the problem that we are going to take today is Chef and Subtree MEXs. The code is SUBMEXS and the prerequisites of the problem is DFS on tree, that is depth first search on trees. So the agenda for today is that first of all we are going to understand the problem statement, then we are going to understand the approach with the help of some examples, and then we are going to code the solution in C++. Okay guys, so let us understand the problem statement. So what is given in the problem is the max of a set of integers is defined as the smallest non-negative integer that does not belong to the set, right? So what is the definition of max? Let us suppose we have been given three integers, that is 0, 2 and 3. So smallest non-negative integer, right? So which is the smallest non-negative integer that is not present in the set? That is 1. Right, 0 is present, 2 is present and 3 is present. So smallest non-negative integer that is not present in the set is 1. Right, so max of these three integers will be 1. Similarly, if we can take another example, the max of 1 comma 3 will be 0. Why? Because the smallest non-negative integer, I did not mean positive, the smallest non-negative integer is 0, that is not present here. So max of 1 comma 3 is 0. 2 is also not present in the set, but we need to determine only the smallest non-negative integer, right? So it is 0. So this is the definition of max, and what we have been given in the question is that Chef has a tree with n nodes which are numbered from 1 to n. So here we can see the example. So let us suppose the value of n is equals to 3. So the tree is defined like this, right? The structure of the tree is this we have taken in the example, and it is rooted with 1, right? So the tree is rooted with 1, and Chef want to assign a non-negative integer to each node in such a way that the integer is between 0 to n minus 1 is assigned exactly to one node, right? So from 0 to n minus 1, which means from here in this particular example from 0 to 2, right? So what are the values that are 0, 1 and 2 we can assign to any of the nodes, right? So we can assign 0, 1, 2 like this, we can assign 0, 1, 2 like this. So in any particular order we can assign a value to each node that is ranging between 0 to n minus 1. Now what is asked in the question is, for each node u, consider the integers assigned to the nodes in the subtree of u and let au denote the max of these integers, right? So what we need to do, we need to, for each node u, we need to consider all the nodes in the subtree of u, right? All the nodes in the subtree of u, and let au be the max of these integers, right? So for each node u, we need to consider the subtree, like for example this one. So we need to consider the whole tree will act as a subtree, and we need to calculate the max of this whole tree, right? And like for this example 2, the only subtree will be this particular node, so we need to calculate the max of this. And at last, what do we want? Chef wants a1 plus a2 till an to be as large as possible, that is find the maximum value of the sum, right? So for each subtree we'll calculate the max, and what do we want? We want to maximize the sum of all the maxes of the subtree that we are calculating, right? So let us understand with the help of this example. So if we assign the number like this, like 0 to node 1, 1 to node 2 and 2 to node 3, so we have assigned all the numbers from 0 to n minus 1 to all of the nodes, right? So if we calculate max, so what is the max of this particular subtree, which consists of only node 2, right? So the value is only 1, so the max of this particular value will be 0, because 0 is the smallest non-negative integer that is not present in the set, right? So the max of this particular node will be 0. The max of this particular node, that is only this subtree 3, will be also be 0, because 0 is not present in the set. And if we consider the last subtree, that is this particular subtree, which consists of the nodes that is 1, 2 and 3, right? So what will be the max? 0, 1, 2 are the values assigned to each of the node, and the max of these will be 3, right? So summing all the values in the end, so what is the value of max that we are getting? The value of max in this particular case that we are getting is 3, right? So this is how the things are working. We need to consider every possible subtree, right? And then we want to maximize this max. So is there any other possible way to calculate max greater than 3? Let us see the particular case. So if I assign, instead of assigning 0 at the node, what we want to assign 0 at the basic level, that is leaf level we want to assign, right? So if we assign 0 at this particular level and then assign the remaining values, so what we can do, we can either assign 1 here or 2 here, right? Or we can assign 1 here or 2 here. So either of the way we can do this. So if we assign 1 over here and 2 over here, observing this particular case, so what is the max that we are getting? What is the max that we are getting is, so here in this particular case for node 2, the value is 0, so the max will be 1, right? Smallest non-negative integer that is not present in the set will be 1 because 0 is included. For this particular node, for node 3, the value is 1, so smallest non-negative integer that is not present in the set is 0. And for the whole tree, since 0, 1 and 2 are included in the set, 0, 1 and 2 are included in the set, so smallest non-negative integer that is not included, that means the max of all of these values will be 3, right? So at last, summing this value and this value, so the answer will be 3 plus 1, that is 4. So we can see that when we assigned 0 at some lower levels, right, or basically the leaf level, so we are getting the maximum max, right? So the maximum max for this particular example will be 4, right? So this is the observation that we made while reading and understanding the question. So let's finally go with the approach and understand what the approach is. So do you know, guys, that you can have access to such amazing content on Unacademy platform? So what you can do, you can download the Unacademy app, or you can go to the website, that is www.unacademy.com, and start learning from there. So what you all need to do is select the goal as competitive programming, where what you will get, you'll get such top quality educators of the country, right? So here you can get ICPC world finalist and IOI medalist, and the educators who have been working in the product-based company, large product-based companies such as Amazon, Google and Microsoft. So these all educators are here on this platform to guide you, to mentor you, and to clear all your doubts regarding competitive programming, right? So what you can do, you can also get the plus subscription, where you can easily solve your doubts with the mentors that are provided to you. These mentors are 6-star and 7-star coders on CodeChef and got high ranking on other platforms too. So the doubt solving will be awesome, and there's a platform where you can discuss your doubts with other members and the other colleagues in the competitive programming, right? So doubt solving, understanding of the concepts will be awesome in this particular program. So why to wait for this particular program? Go and get access to this, get the plus subscription on the Unacademy platform, and also you can use my referral code, that is Chirayu Jain, and get an instant 10% discount on the particular course. So go and get the course. Okay guys, so let us quickly understand the approach of this particular problem. So we have seen various trees over this particular slide. So for each tree, we will calculate the maximum max that we are going to have, right? So we have seen in the problem statement, and then the example that we took in the problem statement, that if we assign 0 to the root node, then what will happen? The only subtree which will include 0 is this particular subtree, right? This particular subtree, the whole subtree, that means the whole tree, right? So the only value of max that we can get is from this whole tree, right? So at all the subtrees, the value of the max will be 0, because this node is not included in all the rest of the subtrees, right? So what we will try? We will try to assign 0 to that particular node at the lower level, which will include maximum number of subtrees, right? So let us suppose we assign the 0 at this particular node, right? So let us see the possible configuration that we can get. So if we assign 1 over here, 2 over here, 3 over here, 4 over here, 5, 6, 7, 8, right? So these are the possible configuration that we assigned. So what is the value of the max that we are getting? So if we consider this subtree, then the value of max will be 1. This particular subtree, the value of max will be 2. this particular subtree, right? So all the nodes, all the child nodes must be included from the parent node, right? So this particular subtree, the value of the max will be 5, right? And for this particular subtree, the whole subtree, the value of the max will be 9, right? And rest all the subtrees like this particular subtree, this particular subtree, this particular subtree will have the max 0. Why? Because the node 0 is not included. We include 8, we include 7, 8, we include 6, 7, 8, right? So node 0 is not included, right? So the rest all the subtrees will have the value 0. So here, considering the subtrees which included the node 0 and rest all the other nodes in the linear fashion, we have these possible answer of the subtrees. And at last, summing the values, that is 9 plus 5 plus 2 plus 1, that means 9 plus 5 is 14 plus 2, 16 plus 1, 17. So 17 is the max that we are getting, right? So if we assign the value at different nodes, so what is the maximum value that we are getting is 17 from here. So we have seen from the leaf level we need to assign the 0, right? So let us take some other approaches. So these two approaches are very important to understand this particular problem. So if we assign 0 from here, right? 0 from here, and then assign all the values, that is 1, 2, 3, 4, 5, 6, 7 and 8, right? So what is the max that we are getting for this particular subtree? That is 1. If we consider this particular subtree, which includes all the 3 nodes, the value of the max will be 3. And for this particular whole tree, the value of the max will be 9. The value of the max will be 9. And rest all the subtrees like this particular subtree, this subtree, this subtree, similarly as we have seen in the previous example, will have 0 values because 0 is not included in the set, right? 0 is not there in the particular group, so the smallest non-negative integer will be 0, right? So we'll take these subtrees and the value of the max will be the summation of all the maxes of all the subtrees will be 9 plus 3 plus 1, that is 13, right? But if we assign 0 at this particular level, like at node 9, 0, 1, 2, 3, 4, 5, 6, 7 and 8. So we have assigned the values like this. So what is the summation of maxes of all the subtrees? So if we take this particular subtree, then the answer will be 1, the max will be 1. This particular subtree, which consists of 8 and 9 nodes, the max will be 2. 7, 8 and 9 nodes, the max will be 3. 6, 7, 8, 9, the max will be 4. 3, 6, 7, 8, 9, the max will be 5. And at last 1, 3, 6, 7, 8, 9, the max will be 9, right? So if we consider this particular branch for assigning the values, then this is the maxes that we are getting, and these subtrees will have the max 0 because 0 will be not included, right? So the summation of these particular values is 1 plus 2, that is 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5 15, and 15 plus 5, if I'm not wrong, then the answer will be 24, right? So this is the way we are getting two different values of the summation of maxes of the subtrees if we are taking this particular fashion and this particular fashion. So this determines to a solution that we cannot assign randomly values to each node. Like we have taken a particular leaf node and we have assigned all the values. We need to think that which particular leaf node we need to take to assign the values, right? So here also we can see, in this particular example also we can see that here in the second example we have seen that the depth of the particular branch, will take that branch, but this particular condition will not work out here. Why? Because we have seen the longest depth is here, but the maximum number of nodes that we are getting over here is more. The nodes that we are getting over this particular subtree are more. So if we assign the values from here, right, so 0, 1, 2, 3 and the remaining value, that is 4, 5, 6, 7, 8, 9, 10, like this, right? So if we assign the values like this, so what is the max that we are getting is 1 plus 2 plus 3 plus what are the total number of nodes? That is 10, so 11, right? So this is the max that we are getting, right? But if we assign the values from here, like this branch 0, like this, right? So 0, 1 2 3 4 5 6 7 8 9 and 10, like this, right? So what is the max that we are getting for this particular tree, that is subtree, that is 0, so 1. For this particular whole tree, what is the max that we are getting? So we have node till 6, values from 0 till 6, so 7. And for this whole tree, the value is 11, right? So we can see in this particular case that this particular answer will be greater than this answer, obviously, right? So here we are getting that is 6 plus 11, that is 17, and here we are getting that is 19, right? So this answer is greater. So what we need to do, what we need to apply the approach, we have seen with the help of examples that depthness or the number of nodes won't matter. At each level we need to calculate the max and what is the maximum max that we are getting from both the left and the right subtree, and the subtrees that we included in a particular node. So at every subtree we need to calculate the max that we are getting, and we need to identify the maximum max. So what is the approach? Let us understand the approach formula. So what we need to do, we need to take two things, that is max and size at each particular node, and calculate that. So we'll initialize max with 0 and size with 1. So if we consider this particular tree, so what we will do, we'll apply the DFS on it, right? So we'll reach the leaf level at this particular case and we'll assign the value. So what we will do, we will assign the max value for the base case as 0 and the size is 1, right? So at each leaf level the max will be 0, obviously, if we take the value as a non-negative integer, so it is 0 and the size will be 1. This is the base case. And then what we will do, we'll see in the DFS we'll return the pair that is max plus size for each subtree, that is the total max that we are getting and the size. So this is the following pair that we are going to return. So let's see how. So in this particular case the max is 0 and the size is 1, so returning the pair will form max plus size. So 0 plus 1 will be 1 and the size is 1. So this is the pair that is returned. So at this particular level, what is the max that we are getting? That is 1. And what is the size that we took? That is only this particular node, that is also 1, right? So DFS is performed to 2 and then it will return this. After this, after encountering 1, the DFS will go at this particular node, that is 3. So same value of pair is assigned to this node as well, so 0, 1. So what will it do? We'll increment the size. So till now the size was 1, but we'll increment the size continuously as we encounter each and every node in the DFS. So the size from 1 will now be 2. The size from 1 will now be 2 and the max is 0. So what is the pair that it is going to return is 0 plus 2 will be 2 and the size is 2, so 2, 2. This is the following pair that is going to be returned, right? So at this particular level where we call DFS, what we are going to do, what we are going to see, we are going to compare the what is the value of the maxes that we are getting from both the subtrees, and then we'll take the max value. So the value of the max from here is 2 and the value of the max from here is 1, so we'll take the value 2, right? And the value of the size is 2. The value of the size is 2, right? So this is the possible combination that is forming here. So what we're going to return, we are going to sum these value of maxes and the size, and then we're going to return the pair. So max plus size will be 4 that we have seen in this particular formula, and the size is 2. So 4, 2 will be finally returned from 1, and this is the possible pair that we are getting. So the maximum value of the max that we are getting is 4. That is this particular first portion, and the size is 2. So we are not concerned with the size, we are concerned with the particular max that we are getting. So this is the particular approach that we are going to apply for this particular problem, like performing the DFS and calculating max and size at each and every node and returning the pair of max plus size, size, right, from each and every node. And at last, what we are going to find, we are going to find the max, and we are constantly increasing the size. And when we need to compare the maxes for both for any of the subtrees, so what we are taking the max of all the maxes that we have, maximum of all the maxes that we have, right? So let us code this particular approach in C++. Okay guys, so now let us look at the code of this particular problem in C++. So what we are doing here, we are making a vector that is v, in which we'll store the whole graph, right? So we have been given, like, let us understand this particular test case. So if we have 2 test cases, and for each test case we have been given an n number of nodes, so what is the ith value that is giving us the value of the node which is the parent node of that particular ith value. So if we look at this particular thing, so the number of nodes is 3 in the first test case, and what is 1 1 determining? These are the n minus 1 nodes with their parents. So the parent node of second is 1 and the parent node of third is also 1. Since 1 is root, right, so it does not have any parent node, and from 2 till n we have been given the parent nodes. So here the ith value is determining it is starting from 2 till the n, right? So the parent node of 2 is also 1, the parent node of 3 is also 1. Similarly, if we see for n equals to 5, right, so if the root node is 1, then from 2 till 5, what are the parent nodes? The parent node of 2 is 1, the parent node of 3 is 1, right? And similarly, the parent node of 4 is 2 and the parent node of 5 is also 2, right? So these are the things. This is how the test cases are working. So we determined a vector, a 2D vector, and first from I equals to 1 till I less than equal to n, I cleared all the spaces of that vector, right? And then I am asking for the parent, right? So which is the parent of that particular ith node, right, starting from the 2 till n, right? So I am taking the input p as the parent value, and I am pushing the value of the ith node, like this is the parent node, right? So vfp determines the parent node, and what are its children? The value of the children is the ith value, right? So vp dot pushback I, it denotes that for the particular parent p, these are the child nodes, right? So this is how I'm entering the value, and then I'll call the DFS, as we have understood in the approach that we need to apply DFS over here. So I'll call the DFS from the root node 1, right? So I'll call the DFS at the root node 1, and I'll look at how this particular DFS is working, and let's see in the code how this DFS is working. So from the root node 1, I'm initializing this DFS, and as we have seen in the approach, what we need to initialize? We need to initialize the max with 0 and size with 1 for every particular node that we are traversing on a DFS structure, right? So first of all, we'll call the DFS for the nodes, right? So int u determines the value which we are encountering for the particular node, right? So we'll take the DFS, we'll again recursively call the DFS until we encounter any particular node which does not have a child node, that means the leaf node, right? So we'll calculate this DFS, and what we are doing, once we encounter a leaf node, we are calculating the max. So what will be the max? The temp dot first, at last what we are returning is temp, a vector, a pair which consists of two values, right? One is max, another is size, as we have seen in the approach. So the maximum value of max comma temp dot first means the first value. The pair temp has a first value which determines the max that we have calculated till now. So the maximum of these two values will be stored in max, and we're increasing size constantly. That means temp dot second, the second part of the pair is storing the size, right? So we're incrementing size constantly. At last, what we will return? What we will return? That is max plus size, as we have seen in the approach. Max plus size we will return, comma size, that the size of the subtree that we are getting till now, plus the max that we are getting till now, the total max, that is max plus size is the total max that we are getting till now, right? So we'll return this thing, and the whole code will work as we have seen in the approach for that particular tree with number of nodes as 3, right? So this is the whole code, that is the DFS we are calling, and at last what we will get? We'll get a pair which will have two values, that is max and the second value is size. So what we need to print down? We need to print down only the max that we are getting, the maximum max, right? So it will be contained at the first part of the pair. So we'll print dfs.1, we have called the function for the root node, and then we'll print its first value. That is all what we are getting over here, right? So this is the whole coding structure, and now let's run this code. Okay, so for this particular input, we are getting the value that is 4 and 9. That is the right value of the sample test case. Now it's the time to submit this particular code on CodeChef. Okay, so now let's submit this particular code on CodeChef. The solution is running, and let's see what we are trying to get. The perfection sign AC. Can we get that or not? Okay, so the answer is correct, and we got the perfection sign AC.